Hello. Good afternoon, good evening, everyone. Oh, I'm sorry. And welcome to another episode of Jappy with Physics. For today, today we're gonna be having more example, cause from a secret someone sent me this example or exercise, and we're gonna solve it. Yeah, I'm gonna try to discuss it. I'm gonna try to explain it a little longer. So if we take 1 hour, 2 hours, it's okay. Okay, it's okay. But I'm gonna summarize the answers. So feel free to like click on the time where the answers will be. Click the shortcut. But I will try to explain it for everyone so they know how the answer or how did I come up with the answers. Okay, for today we're going to talk about physics and these problems. I hope you guys see this. Wait, let me check the video. The video seems good. Let's start. Let's start. Okay, so for number 1, it seems to be a multiple choice problem. An engineering student is asked to describe physics. Which one of the choices best describe the unit physics? Motion and energy. B, all about the balance of quantities. Course that tackles different elements. No. That's chemistry probably. Talks about forces and how it reacts. Statics. All about balance of quantities. Statics again. Science of motion or energy. Yes. Physics. Statics, we tackle about forces. Physics, we tackle about forces. And also, statics is under physics. So, but we also tackle about temperature. We also tackle about other stuff in physics. So, A is the answer. I'm gonna write A. Okay? So, 2 points. Ang was asked about a physical nature of a quantity and what gives you the numerical value of constraints of proportionality that may appear in the algebraic equation. Seems like dimensional analysis. Which of these would be the correct item? Dimensional analysis. Physical balance. I don't think there's such a thing as physical balance. Probably forces, right? But it's not numerical value constraints. Accuracy, precision, no. Right. Accuracy is the word for getting the true value or getting near the true value. You're very accurate if you have the true value. It's if you measured near the true value, while precision is the difference between values of measurement. Okay. And numerical value constraints of proportionality is about dimensional analysis. Okay. The one with the M over L something. Mass over length. Cube is density, something like that. Right. Number 3. Isaac Newton stated the 3 laws about motion. Law of inertia, law of force, law of inertia, law of motion, and law of reaction. Action and reaction. Yeah? Which of the following choices do not follow the 3 laws? A rigid body will apply an opposite reaction to the action applied. Yeah, okay. An object at motion will stay at motion unless acted upon by... Oh, this one is the inertia. An object at rest will have no forces acting on it. SAS. Okay? So, not necessarily because when there's like 2 Newton going to the right and 2 Newton going to the left, the object will stay at rest. But not necessarily there are no forces acting on it. The acceleration of an object multiplied to the mass is force. Okay? Acceleration of motion. Acceleration, the law of motion. A rigid body will apply opposite reaction. Law of action of reaction, law of inertia, and law of acceleration. Yeah, the third one is the answer. Okay? There's no such thing as a zero forces. Wait, let me just fix my... So, letter C is the answer for number 3. Okay, I hope you guys are following. I'm trying to explain every question. Okay. If you guys have any questions or if you have something, if you have any concern about the question, please feel free to comment below. Or, if you guys have learned something, please free to like and comment below. Subscribe. Thank you so much. The master of all elements, yes, the avatar, bended the rock in front of him towards an enemy. Pew! Okay, with extreme force over a distance. You would say he exerted change of temperature? No, it moved. Distance. Yeah, distance traveled by the rock, but Ang did not exert it. Pressure? No, no. Pressure. I haven't discussed pressure yet, but pressure is over an area. Work, yes. The answer is work. Okay. Right. The Daily of Earth Kingdom have captured Appa, oh no, and said that they have to borrow a certain standard cylinder platinum. What? Iridium at the International Bureau of Weights and Measures in order to measure Appa's watt quantity. Okay, Newton, kilogram, mass. Okay, so this is more of a concept. Okay, and before, I think it's 2019 or 2018, we measured the standard unit of mass, or the standard unit for mass is the platinum iridium at International Bureau of Weights and Measures. But recently, I think it has been changed into some sort of nuclear material. Recently, it has been changed because it's more I think it's not nuclear material, but some kind of polymer. It's more decay resistant or decomposition resistant. It's more consistent, right? It's more standardized. Anyways, Newton is a force, plus we don't have the definition. Force is mass times acceleration. Kilogram is a unit of mass. Okay. Weight is another force going downward, right? So the definition for mass is this one: see linear platinum iridium at the International Bureau of Weights measures in order, right? And actually, you could argue that actually the cylinder platinum iridium is actually 1 kilogram. So if this is 1 kilogram, it could be the right answer. Okay? Because 1 kilogram is the platinum iridium at the international. But Appa is not 1 kilogram. Ang was under pressure. He needs to master all the units, not the elements. Which one is different among the rest? Kilogram, pounds, liters, ounce. Ounce is mass. Kilogram is mass. Pounds is... Normally, it can be mass and force. But since... I think since it is not... pound mass is not highlighted or emphasized, this will be assumed as mass. Okay, if it's normally pounds only, it should be mass. Okay, then liters. Okay, liters for volume. Okay, so liters is the different among the rest. This represents maximum speed that a particle mass can achieve. This is under definition of light, or this is under definition of time. 1/299792458, or the value of speed of light, which is 2.9989 times 10 to the 8 times 10 to the 8 meters per second, which the answer is letter C. Letter A, which is C. Okay, which is letter C is speed, is a Mach number. This is the speed of sound. Okay, and letter D is acceleration due to gravity. Okay, and it is said that the speed of light is the maximum speed that a particle could achieve. A particle of mass. Okay, then it turns into energy. The set units represent the quantity pressure except not a unit but a formula, force over area, plus there's no such thing. There's a unit, Faraday, but it's not a unit of pressure. Okay, Newton per meter squared, yes, unit of pressure. Kilogram per meter second squared, yes, a unit of pressure. Remember that the dimensional analysis of pressure is m/LT squared. Okay, remember guys. LBF or PSI. pound force per square inch. Okay? So the answer for number 8 is letter A. You were given 4 units of length. Which of the following will have the highest value? Okay, 1 feet. Obviously, 1 feet is greater than 11 inches. 11 inches because 1 feet is already 12 inches. How about we convert everything into inches, right? So 12 inches, 11 inches. My handwriting is very beautiful, as always. Thank you so much. 28 centimeter, 28, 11.0236, 28 centimeter conversion. 1 inch is 2.54 centimeter, and that will become 11.0. Oh, sorry. 0236, meaning feet is still winning. Okay? Mile. Let's convert mile. 1 mile is 5,280 feet. 1, 2, 3, 4, 5. Yeah, that's it. Times 5,280 feet times 12. And that will be 0.63636. So this one is 0.06336 inches. The winner is 1 feet. Okay? It has the highest value among the units of length. That's a conversion question. Ang have mastered equilibrium and balancing of forces. Way to go, Ang. Way to go. You have balanced the earth. He said that in any object, shape, or form, all center of gravity will be located at the center of the object's height and weight. No. I mean, in any object, shape, or form, how about a boomerang? It's not in the center, no? How about a triangle? I mean, technically, it's in the center, but it's at the 2/3 height. It's not in the middle. It's not in the center of height, okay? So that's a no. First statement is wrong. He also said that further, you have not mastered equilibrium and balancing of forces. I was ashamed. He also said that the farther force is applied, the bigger the moment torque produced by force. Yes, torque is force times distance, right? So the bigger the distance, the higher the torque or higher the moment. So second statement is true. First statement is false. Okay, so letter C. If you have 2 kids, the left and the right, if you have 2 kids, one is double the size of the other. Okay. Where to play on a seesaw? Which of the statement is true? Both should balance out in equal amount of length. The larger kid should be twice farther from the center. So, the larger kid will be L, which is twice the small kid, right? So 2S and S, right? And if they are to balance, the torque will be 2S times distance is equal to S times distance. So the distance of the kid should be the distance of the bigger kid, cancel. This is the biggest distance of the bigger kid, and distance is smaller kid. The distance of the bigger kid should be the distance of the smaller kid divided by 2. Okay? Long story short, the bigger kid should get nearer to the center. Okay? And the distance of the smaller kid should be farther to the center. The larger kid should be twice farther from the center than the smaller kid to the balance. Okay. The smaller kid should be twice farther from the center than the larger kid. The larger kid should be twice farther. Oh, that's wrong. C is the right answer. The smaller kid should be twice farther from the center. The smaller kid should find a new same... What? No. Okay. Consider a bullet is fired horizontally. 500 meters per second with 500 kilos and 500 kilos drop vertically at the same time. At the same time, which of the statements true? The bullet will touch the ground first. The ball will touch the ground first. Both will touch the ground at the same time. None of the above. Well, it's not actually depending on the time, but it depends on the height. It doesn't depend on the velocity vertically. It doesn't depend on the mass, and it doesn't depend on the mass of the other object. It depends on the height. Okay, but this is so D, none of the above. We cannot say for certain because there's no height given. There's no height given. It's not about time, it's not about mass, it's about the height. Okay, which of the following set of coplanar forces can't be in equilibrium when applied? This is in the topic of free fall, by the way, number 12. Which of the following set of coplanar forces can be in equilibrium when applied on an object? 5 Newton forces. Oh, this is more like a cosine law. 5 Newton can be set in 60 degrees. 6, 8, 10 forces. How about 6, 8, 10? Okay. In order to make a balanced equilibrium of 3 forces, we need to make a triangle. Okay? And 6, 8, 10, right? If we make a triangle, right triangle, 6, 8, 10, 6 squared plus 8 squared, 36 plus 64 is equal to 100, which is equal to 10 squared. Okay? So B is correct, A is correct. 1, 2, 3. 1, 2, 3. We can't. Okay? Because the hypotenuse cannot be the same as the addition of the two sides. The two sides, the base and the height, should be longer than the hypotenuse. But we can still put this on equilibrium. 3 to the right, 1 to the left, and 2 to the left. And this could be in equilibrium too. I think the answer is letter D. Okay? Because whatever we do, the smaller sides is not longer than the, okay? A triangle must have the sides. This is more of a trigonometric question, but on a topic of forces. Okay? A triangle must have longer sides when you add both of them than the hypotenuse. Because if that's shorter, it would be enough to make up with the triangle will be like that realistically. Okay? The triangle will be like that realistically. It's not gonna be a triangle or a polygon. Okay. 5 Newton forces applied horizontally and 10 Newton forces applied vertically on a body. Which of the statement will be true? 5 Newton force horizontally, 10 Newton force vertically. Okay. Which of the following statement will be true? The body will remain at rest? No. Horizontally and vertically, it will move. The resultant force will be greater than 10 Newton. Yes. Because 10 squared plus 5 squared is 100 plus 25. That's already 125, and the square root of 125 is probably 11 point something. Okay. The resultant force is 15 Newton. No, it's gonna be 11 point something. Yun, just mental math. The body will react at the opposite reaction. Well, there's no friction included. So, the answer will be letter B. Okay? No one said about friction. There's no friction about the problem. The only sure thing will be letter B. Okay? Given the diagram box A and box B, below which box B is in pending motion, what would be true in the choices? Normal force of A is perpendicular to the normal force of B. If this is your object, this is B, this is A, the normal force for B will be, okay, going to the upward, because the B is going upward. Then the A will have a normal force going, well, it's not perpendicular, it's more or less parallel. So A is wrong. Friction force A is direction fourth quadrant. If given that the variable box B, which is in pending, if B is in pending motion, it's going downward, right? Going downward. Friction of B, or friction of the ground, is going upward, then friction of A is going upward too. It's gonna stop B going downward. Okay, so wrong. Okay, because friction of A is going to the second quadrant. There will be 5 forces acting on B. Well, the weight, right? The weight. Okay, this is just motion. Okay. Is there anything else? Normal force, weight. Is there any existent force? No. Okay. I think that's it. Okay, so letter C is correct. Tension of the cord on A is equal to the weight of the B. No. Okay, no, because there's friction on it and there's not enough. I think there's no friction coefficient given. There's not enough data to make sure of it, but it won't be. You know, generally speaking, friction doesn't B will not be able to sorry, if we are to prevent motion in it, B's weight will not be equal to the tension. The tension should be greater than B's weight. Okay? So no. Okay, so letter C is the answer. Okay. Alright, what else? We're getting through this. How many time is it? Time check. 21 minutes. So, we're doing pretty good. While flying above the clouds at steady velocity, Ang was struck by lightning, free-falled into the ground. Which of the statement will be true? This is more like work power energy. Electric energy exerted work on Ang and made him fall. No. Okay, so what happened is the electric energy fried probably Ang's body and it turned into chemical energy, or probably, I don't know. But it can't make him fall. You know, electric energy can make him float by a magnetism or something, but fall if there's a magnet downward, or if there's an electric field downward, but no. Electric energy will be converted to kinetic energy. No, that's not how lightning works. You know, it's not the Flash. Okay, if you get hit by lightning, you don't become the Flash. Okay, that's only in science fiction. So no. Ang's kinetic energy will be equal to the loss of potential energy. Yes, because he will be falling. Ang's kinetic energy will be equal to the loss of potential electric energy by lightning. No. Okay, so letter C is the answer. Okay, electrical energy is not included in the statement. He's probably exerting force, then the lightning probably knocked Ang out, but it's not part of falling. Okay, Ang have traveled to another planet. He said that compared to the Earth's gravitational pull is half in the other planet. Which one would be true? The gravitational pull is half, okay, on the other planet, okay? New, okay, the new planet. The mass of the new planet would be half of the Earth, probably. Objects at any angle will have lesser coefficient. There's no such thing. I mean, friction is not related to gravitational pull, probably not yet. The weight of the object will be the same. No, weight will not be the same. Okay, because weight is a unit of force. The mass will be the same. Okay, so A is the answer. Okay. Okay, remember the formula? F is equal to mass 1, mass 2 over d squared, capital G. That's the formula for Newton's law of gravitation. For number 16, we use the work is equal to potential energy plus kinetic energy. You know, since Ang is flying, he's exerting work, but you know, he stopped flying because he got hit by lightning. So 0 work will be negative PE plus KE, okay, or equals to K. Okay, I think that's about it. I mean, I've shown you all the formulas and calculation. Ang was running at a certain speed. So Ang was running, you know, at the speed of wind, until he was pushed by a speeding boulder. He got hit by a speeding boulder almost instantly, sent by an earthbender. Which one of the would explain the change in motion? Instant. Okay, so anything that has a slope will be, or as uniform slope will be uniform motion, and a form of instant is going instantly upward. Okay, just a change to shift of velocity. So the answer is letter C. I'm training to be the avatar. Okay. I'm training to be the avatar holding a glass of water, 0.2 kilogram at shoulder height, 1 point holding. So he is holding a glass of water. Okay. Let's do a Powerpuff Girl hand. Okay. This is the glass of water. Powerpuff Girl hand is very easy to draw. So imagine that's Ang San. Blossom Ang. Avatar Blossom, the last Ang bender. And anyways, he steadily held it for 3 days. Which one of the statement would be true? Ang exhausted the work at least 2.354 joules. Ang is not exerting any work. Ang exhausted the work of 600 kilojoules. None of the above is true. So the answer would be letter B. Because work needs to be force times distance. In order to have work, there needs to be a change of displacement. Yes. Right? But, sir, Ang is getting tired. He must be exerting work. Probably because of the chemicals in your arms, you're breathing oxygen, your arms is being stretched out. The oxygen in your arms, in your muscle is is disappearing, but in terms of mechanical work, there's no change of distance or displacement, so there's no work exerted on the glass. Okay? Probably on your muscles, on the change on the oxygens, probably, but not on the glass. Okay? And besides, we're physics, not biology. We're in physics, not in biology. Okay? Ang have noticed that he was holding alcohol. It is said that the alcohol is less dense than water. Which of the statement would be true? Ang have noticed that he was holding alcohol. It said that the alcohol is less dense than water. Which of the statement would be true? Ang could carry more weight of alcohol than water. Ang could carry more mass of alcohol than water. Ang would require more space. So alcohol is less dense than water. So meaning alcohol mass over volume. Alcohol water mass over volume. Okay? So volume is always assumed as 1. So when we have 1 kilogram per meter cube of water, if alcohol is less dense, probably 0.5 kilogram per meter cube of alcohol, not aluminum, the denominator is always 1, right? So if they have the same volume, Ang could carry more weight of alcohol than water. No, Ang doesn't change. Ang could carry more mass of alcohol than water. No, Ang doesn't change. Okay, so if you can carry 1 kilogram both, you can carry 1 kilogram. Okay, Ang would require more space for alcohol than the space weight than water. Yes, because in order to get 1 kilogram of alcohol, you need to have 2 meter cube of alcohol, while in order to get 1 kilogram of water, you need 1 meter cube of water, because that is dimensional analysis. Okay, so letter C. Ang would require more space for alcohol of the same volume. Oh wait, no, not that's here. I'm wrong. Letter D. Okay, same volume. Okay, same weight. Oh wait. Wait. You're so C is the answer. Okay, C of 1. Same mass. Okay, if there's 1 kilogram of alcohol, 1 kilogram of water, the volume for water is 1 meter cube. The volume for alcohol is 2 meter cube. So Ang would require more space for alcohol, okay, of the same weight. Same volume, no. If there's 1 meter cube of alcohol, there's 1 meter cube of water, the mass is lighter, but in terms of space, they have the same volume, so it's the same, you know. Okay, so that's the 20 questions, okay? That's the 20 questions for multiple choice. We're gonna be going to problem solving. How many minutes is that? We have used 30 minutes, okay? 30 minutes with explanation, okay? So I hope you guys are, have learned something and, enjoying the longer, more explaining videos. Okay? Tell me if it's getting, if you don't want longer, if you want shorter, but, as much as possible, I want to, like, teach, or I would like to impart what I know. Then you guys could say, hey, Jumpy, you're so stupid, that's wrong. Okay? Anyways. Okay, we're gonna be continuing to part 2 of the video. So, thank you so much, guys. I'm gonna end this. And see you guys to part 2. Thank you so much, guys. I hope you like and subscribe. And if you have any questions, please comment below. Bye-bye.